All right, let's do this more solving. We have more solving going on here. So, first example, how do you get rid of that log base 2 again? If you remember from the last video, you're going to change those to exponents. So we have 2 raised to the log base 2 of x is equal to 2 raised to the negative 1. So bang, bang, that goes away, and you are left with x is equal to 1/2. Remember, 2 raised to the negative 1 power does not make it negative 2. It means you take the reciprocal and you get 1/2. Next example, first thing you got to do is subtract 2 from both sides. That's going to give you 8 natural log of x is equal to 28. Now you're going to divide both sides by 8. So you're going to get the natural log of x is equal to 7/2. Then to get rid of the natural log, you need to make e the base of both sides, and that will cancel the e and the ln. So you have x is equal to e to the 7/2 power, which is approximately 33.115. All right, that's that. Next example, we have log base 2 on both sides. That makes this question pretty easy because log base 2 has to have the exact same number on both sides, so that means you're just going to set these equal to each other. And you're going to end up with 2x is equal to 18, so x is equal to 9. No big deal. This next one's a little bit tricky. The first thing you're going to want to do is you're going to want to switch this up a little bit. So we're going to just switch these two pieces because we know as a little shortcut from Algebra 1, if we switch those, we're just going to get 4/3 is equal to 2 plus 3e to the negative x. And now you're going to subtract 2 from both sides. That's going to give you a negative 2/3 is equal to 3e to the negative x. Divide everything by 3. That'll give you a negative 2/9 is equal to e to the negative x. And now what you need to do is you need to take the natural log of both sides, and this is when you're going to have a little bit of an issue. So as soon as you try to take the natural log of both sides, the natural log of negative 2/9 is not possible because you can't take the log of a negative. So in this case, x has no solution. Okay? So that was a little bit of a tricky one right there. Next example, again, we need to get that 2 log base 3 of x by itself first. So the first thing you're going to do is subtract your 3 from both sides. That'll give you a negative 2 log base 3 of x is equal to a negative 10. Divide both sides by your negative 2, and that's log base 3 of x is equal to a positive 5. And again, how do you get rid of a log base 3? Well, you need to exponentiate both sides, which means those are going to become exponents, and your base is now a 3. So 3 raised to the log base 3 of x is just x. They cancel each other out, and 3 to the 5th power is 243. And that's it for that example. The next one, tricky. You've got 2 natural logs on one side, and you have 1 on the left. So you need to use some condensing properties here from one of the previous videos. So we have the natural log of x plus 5 is equal to condense this side, you have the natural log of, when you subtract, you should remember that that is division. So we have the natural log of x minus 1 over x plus 1. That's what you need to do first. Okay, so now that you have ln, you're just going to take e of both sides, and that's going to give you your x plus 5 is equal to x minus 1 over x plus 1. So now you just need to solve. So you need to multiply both sides by the x minus 1, or by the x plus 1. Those will cancel, but now you'll have to FOIL the left, giving you x squared plus 6x plus 5 is equal to x minus 1. And I think you know what you're about to do here. You're about to subtract everything to the other side, giving you an x squared plus 5x plus 6 is equal to 0. So you have an x plus 2 and an x plus 3 equals 0. So x is equal to a negative 2 and a negative 3. So now you actually need to check and see if they work. So if you substitute into the original equation, you are going to find out that, substituting a -2 in here works out just fine. But earlier we said, can you take the natural log of a negative number? And the answer was no. So if you substitute the -2 into here, it's not going to work. So this answer, again, is no solution. And your extraneous solutions are going to be -2 and a -3. Okay, so you got to be careful with that. You always have to double check your answers when you've got something that funny could happen. Finding inverses. We know that finding inverses is basically switching x and y and solving for y again. So we know this is actually x is equal to the natural log of y minus 5. So now in order to get y minus 5 by itself, we need to take e of both sides. So this becomes e to the x is equal to e to the ln, which is going to cancel that out, which is just going to give us our y minus 5. So all you have to do is add 5 to both sides, and you're going to get that the inverse is equal to e to the x plus 5. All right, that's it for that one. Last one is, how long does it take to make $1,000 turn into $1,350 if you're getting a 5% interest rate per year compounded continuously? So for this, you're going to have to use your PERT equation. So remember, that one is the amount of money you have in the account is equal to your original amount of money, E raised to the 0.05 times T. So you have everything that you need here except for the T. So the first thing you need to do is divide both sides by 1,000 to get the E by itself. So we have E to the 0.05 T is equal to 1,350 divided by 1,000, which is going to give you 1.35. So now, how do you get rid of an E? You have to take the natural log of both sides to get the E to go away, and that's going to give you 0.05t is equal to the natural log of 1.35 is 0.30010 yada yada yada. Remember, for now you can just round to the nearest 3 decimal places, but you want to leave it in your calculator, and that's going to give you, like I said, 0.300 point yada yada yada. And then all you have to do is divide both sides by 0.05, and that's going to give you t of approximately 6 years. Alrighty, so it takes about 6 years to turn $1,000 into $1,350 if you have 5% interest compounded continuously. And that's it for solving again. This is Longo. I'm out. See you. Bye.